So this one is a velocity versus time graph, and this one is probably the hardest one to describe because there's a couple things you have to consider. Alright, so let's give it a go. I'll split them into sections, 1, 2. You might think this whole thing is one section, but you want to kind of split it into 2 sections from the origin, same as this one. This is section 4, and this will be section 5, because for velocities, the direction matters. Alright, so let me just write something. You know, slope of a velocity graph is going to give you acceleration. Obviously, the area under the curve will give you, well, it depends, it can give you distance as well as displacements depending on what you do with those areas, but I think that's going to be in the further down question, so I'll explain that later. So first of all, let's describe the motion. Let's start with section 1. So section 1 is pretty easy. It's just going to be traveling at 10 meters per second for 20 seconds initially. And then what happens is, so the velocity goes from 10 to 0. So that means the slope is negative. As you can see, it's going downwards. So that means it actually accelerates negatively, so it decelerates. So it decelerates until it's at the origin. And then it comes to a rest momentarily because it's at 0 meters per second. And then so that's, let me just clarify, that's over here. So it's at 0 meters per second. And then what it does is it goes from 0 to 10. So it actually accelerates. Although people might think it's going downwards, you might think it's going, it's decelerating, but actually it's going from, ignoring the minus, it's going from 0 to 10. So it's actually accelerating, but to the other direction. That's what the negative means. So back towards the other direction it came from, it accelerates for 22 to 25 seconds, so 3 seconds. And then what happens is, then it goes from negative 10 to 0, so it reduces the speed. It's 10 to 0, so it's going to decelerate back to origin again. So it changes direction again. And then, so for 5 seconds, and then in section 5, it is going from 0 to 20 meters per second, so it is accelerating. So that is accelerating for 30 seconds now. And yeah, that's basically it. Let's move on. B, state or determine the acceleration of the object between t equals 0 and 20 seconds. So that's section 1. Alright, so section 1, we've got to figure out the acceleration. And over here, I've already stated that it's the slope. Well, hopefully you can see that the slope is 0. Or I should really write A is 0 meters per second squared, because that's what it means. T is 20 to 25, so that is this whole section over here. So slope, let's have a look. You just got to write the acceleration equation, which is delta V over delta T. Yeah, delta V, let's have a look. My final is negative 10. My initial was 10. My time was 5 seconds, so that's negative 20 divided by 5, which is negative 4 meters per second. Alright, and then my T is 25 to 60. So that is, my final is 20, my initial was negative 10. So my final was 20, did I say? Yep, 20 to negative 10. So take n and negative 10, so be careful with that. Seconds is 60, take 25. You just chuck that in the calculator, and hopefully you should get 0.86 meters per second squared. Right, determine the distance travelled by the object in the first 25 seconds of its motion. Right, distance travelled. Right, so we're going to look for the distance traveled for the first 25 seconds. So that is this area here. Let me just double check that's what it was asking. All right. So with the distance, what you have to do is add all the areas under the curve. Okay. So that is what you do for distance, because we're not considering, you know, the displacement, the direction. So what I'm going to do is just write what it is. So section 1 is 10 by 20 seconds. So I'm going to write area plus the second section, which is just that section there, which is 10 by 2 seconds. And it's a triangle, so I've got to divide it by 2. And then my last section, which is this one over here, which is 3 seconds times by 10 divided by 2. Right, so this is what I have. If I do it all together, I get 200